got the idea, and now I would like to go into differentiation rules. So this is the only definition of the derivative function. There is no other definition of f prime. So when we're asked, use the definition to determine f prime, you're stuck. This is the only way. If we are asked, find the derivative, and it does not say, the problem does not say, using the definition of the derivative, then you can do whatever you want. Okay. Good. Differentiation rules. One, power. Two, sum difference. Three, product. Four, quotient. Five, chain rule. So these are the rules. And these are in sections 1.5 through 1.7. Good. So let's start with the power rule. So these are our rules for differentiating powers, sum difference, product, and quotient. Let me have the book open already on 154. So it's ready. Perfect. Okay. So let's start with the power rule. Good. So if we have x squared and we differentiate it, do you remember? Does anyone remember how much did we get? 2x. That's it. That is the power rule. Meaning, if we have x to the nth power and we want to differentiate this, all we have to do is bring down the power as a factor, which means we multiply, times x to the power minus 1. This is the power rule. Nothing else. Now, when we get to the chain rule, I will mention something that has connection to this. Since I already said that, I'm just going to ask you the following. If I have a function that is just x, can anyone give us the slope? It's a line, right? Can anyone give us the slope of this function, which is m equals? This is no calculus. What is the slope? This is just algebra. This question is just algebra.
2?
Do you see a 2 here?
Oh, I'm sorry, 1.
1. Very good. That is the slope. A number or the coefficient if you want, or the number in front of x. Excellent. So please remember, that means that x prime is how much? How much? We're not talking about x squared. So x squared prime is 2x. I'm here on the side, I'm just talking about x. And we said that the slope is 1. So then x prime is?
Would it be just x?
But then it means that x squared prime is x squared. If x prime is x, then x squared has to be x squared, right? This is the slope. That's all it means. That's the rate of change of the function. So x prime is 1. This is it. This is it. So the slope of this line, because it's going to be a constant in this case. So please remember x prime is 1. To be exact and correct when I write this, I should write multiplied by x prime. But why I don't multiply by x prime? Can anyone explain why I don't write times x prime? Because x prime is how much is x prime? Why don't I write times x prime here? I should, but I don't. Because x prime is?
1.
Exactly. Because x prime is 1, there is no reason to write times x prime. But otherwise, you will see what happens when we talk about the chain rule. And that will be a totally different situation, totally different story. So please remember, moving forward, the rate of change of function x is 1. Therefore, the derivative of x is 1. What if I ask you now, if I have the function x equals 7x, what will be f prime in this case? What will be the slope of 7x? That is f prime.
Just 7.
Just 7. Just 7. So coming back to the power rule, x to the nth power prime, we bring down n, we multiply by x, we subtract 1 from the power, and please remember, keep in mind that in the background there is one tiny operation that is not required now, just because it happens that the derivative of x is 1. Good. So let's practice a little bit, and then we'll move on to other rules. So please choose anything you like from 7 through 28 for now. And I just want to mention, because you see here there is a notation. Again, we have several notations for the same thing. Why? Well, it's convenient, and I'll explain. So f prime is the same with the derivative of y, because f of x is the same with y, with respect to x. So these are the same thing. Different notation. Okay, so let's pick and practice the power rule. Okay, I will pick 17, and then you pick the next one. So y equals 4 times x to negative 2. Good. We're asked to find, if you want, this is our f of x. If you like to write f prime of x, if you like to write dy over dx, the derivative of function f or function y with respect to x. We bring down the power, and we have to multiply by 7. So we get negative 8 times x to negative 2 minus 1, which is negative 3. And yes, we should write it like this as the final answer. We review the power rules, the exponential rules. So negative 8 over x to the third power. Any questions on this problem? Please unmute yourselves and ask any questions anytime. Okay, would you like to pick another? If you ask me, I would like to pick 25, 27.
I was gonna say 27.
27 and also 21. So let's look at 21, and then 25, and then 27. In 21, we have y equals 8 to the square root of x. Yes, I have to change this for now, for the first time, into an exponent. Can anyone refresh our memory? The square root of x is the same with which exponential notation? The square root of x, we know all radicals can be changed into exponential notations. How?
X to the 1/2.
Brilliant, thank you very much. Excellent. So I write it as x to 1/2, and now I can write either y prime or f prime or dy by dx, they all mean the same thing. I multiply 8 by 1/2 and I get 4. I multiply by x, but I have to subtract 1 from the power. But 1/2 minus 1 will be negative 1/2. That's why we reviewed the power rules. So this is 4 over the square root of x. Keep in mind, please don't forget, this is extremely important to remember. This is missing something. What is missing is times this x prime. The reason why I don't write it is because x prime is, can anyone say that?
One.
Excellent. Please remember, x prime is 1. And you'll see why I'm emphasizing this now. Okay, I want to look at 25 and then 27. And then you choose if you want to, or we continue. Okay, in 25, so let me copy it. So this is 1/2 x to 4/5. So here's what we remember so far. We remember that x squared prime is 2x. We remember that x prime is 1. And now what I would like us to remember is that the square root of x prime is 1 over 2 the square root of x. So please carve these in stone. And review and review and review and repeat and review and repeat and review. It's like the a plus b squared. If we did not learn it 3 weeks ago, we're going to have a hard time forever. So please review and repeat these forever, so you don't have to get stuck. Okay, so now y prime, I bring down 4/5, 1/2 times 4/5 times x. 4/5 minus 1 is negative 1/5. These are not friendly numbers. These are not friendly functions. They're not. Yes, I'll simplify. So then y prime equals 2 over 5, and x to negative 1/5, remember, is 1 over the 5th root of x. This is awful. It's an awful function. So I have to rewrite it, if you want, dy over dx, whatever you want to write, f prime of x, they all mean the same thing, as 2 over 5 times the 5th root of x. Not a friendly function at all. Any questions, please? Things are getting hairy moving forward. So please stop me or ask questions or anything. Okay, and I also want to look at 27. Here's why. 27 has y equals 7 over x cubed. I have to change it into 7 times x to which power? That's why we reviewed the power or exponential rules. So 7 over x cubed is identical with 7 times x to which power? Very important rule.
1/3.
-3. A to negative n is 1 over a to the nth power. That's why I'm begging my students to redo the problems we do in class and watch the videos. It's the only way to get these embedded in your system. Okay, now this is prepared for differentiation. So then y prime or dy over dx, etc., etc., etc. I bring down -3. It's -21, and I multiply by x to -3 minus 1, which is -4. And yes, I have to rewrite it like this. So please remember, 1 over x cubed can be replaced by x to -3.
Is it required to be in fraction form at the end?
Yes, because it has negative exponents. If you remember when we talked about negative exponents, we said 99% of the cases we do not accept negative exponents in the final answer. Yeah,
Okay, thank you.
thank you. Very good question. Okay, so this is the power rule. Now let's look at someone different. Nothing different. So when we differentiate a sum or a difference, so a function plus another function prime, or a function minus another function prime, we differentiate each function by itself. So this is f prime plus g prime, or of course, if it's minus, it's minus. So this is the second rule. When we add and subtract functions, and we want to determine the derivative. So, okay, of course, some of them are just extensive. Okay, I'd like to look at 51, because 51 is a little bit more complex, meaning in 51, we have y equals x plus 2 over x cubed. And in addition to that, we're asked to find dy over dx when x is 1. Here's how we write it. This is the correct notation. So first, I cannot determine this before I find dy over dx. I have to find the derivative function of y, and then plug in 1. So let's find dy over dx. Can anyone refresh our memory when we differentiate? Because it's a sum. So when I differentiate x, what do I get? This should be instantaneous now. When we differentiate x, we get?
Is it 2x?
Okay, let's take a look.
1.
Yes, it's okay. Good. So we have 1 plus, well, this has to be changed. This has to be changed into 2 times x to which power again?
-3.
Excellent. So then when I differentiate, I'll bring down -3 as a factor, so I have -6 times x to -4. Or 1 minus 6 over x to the 4th power. So I found this piece. In order to find this, all I have to do is write dy over dx when x is 1. So I plug in 1. 6 divided by 1 is 6. So the answer is 1 minus 6, which is -5. Can anyone tell us what does -5 represent for this function? What does this represent for this function when x is 1?
Would
Yeah.
it be the slope of
Yes,
both of the
yes, yes, yes. Thank you. It's the slope of the tangent line to the graph of y when x is 1. I don't know how this function looks like. I don't care. But it means here, when x is 1, the slope of the tangent is -5. Which means the function is rapidly decreasing. Rapidly decreasing. Because the slope here is -5. Very good. Any questions? So, we know for now how to differentiate powers. We understand that the sum and difference is really nothing. I differentiate each function one by one. Now, I would like to look at the product of two functions. So we have all the rules in front of us. Let me